So now we are going to graph these by hand when they are more complex than one step. How do I have to start x squared minus x minus 2 over x minus 1? How do I have to start breaking that down to graph it?
Simplify.
Simplify the top first. So what do I have to do to the top? If I factor it, what factors multiply to give me -2 and add to give me -1?
E.
Minus 2 plus 1. Okay. Can anything cancel? No. So now I have to find all of my asymptotes. How do I do that? Bottom's equal to 0, so x minus 1 equals 0, so x cannot equal 1. There's 1. What else do I have to do? How do you find your y asymptote? Look, this is a square, this is a x. There are no squares there. So if the top is larger than the bottom, okay, I have to set up my slant asymptote of y equals x. Which means that I have an asymptote that goes this way. Okay. So I have an asymptote of y equals x. I have an asymptote of x equals 1. Now I need to plug numbers in and graph. Plug and chug. Okay. I need to plug in numbers on this side, and I need to plug in things that are in between. So let's plug in -1, -2, and -3. If I plug in -1, I get -1 squared minus -1 minus 2 over -1 minus 1. So up top you get 1, 2, you get 0, right? 0 over -2, which is 0. So when I plug in -1, I get 0 out. -1, 0.
Do you have to have 4?
I need to plug in 3 points from this side and 3 points from that side. When I plug in -2, -2 squared minus -2, -2. So -2 minus 1. I get -3 on the bottom. Up top I have 4. Here I have 2. 4 plus 2 is 6. Minus 2 is 4. So I get -4 3/4. -4 3/4, so -1 1/3. Ooh, that's going to look weird. That's not going to work. It does if my graph was drawn correctly. If my numbers were like on an actual graphing line. So -1 1/3 would be like here. Okay, so this is going to curve this way. Then I'm going to come over here and plug in +2, +3. If I plug in +2, I have 2 squared minus 2 over 2 minus 1. So I get 0 over 1. So 2, 1 is the solution. Then if I plug in 3, I get 3 squared minus 3 minus 2 over 3 minus 1. On the bottom I get 2. Up top I have 9 minus 5. So I get 4, which gives me 2. So I have 3, 2 as a solution. So 3, 2. So this one's going to curve like this. And I have graphed my points. Okay. How do I do x squared minus 4 over x squared minus x minus 6? What do I need to do first? What do you need to do first? No. Simplify the top and bottom. So what's x squared minus 4? That's a difference of squares. How does that break up? X minus 2, x plus 2. The bottom, what multiplies to give me negative 6, adds to give me negative 1. Multiplies to give me negative 6. Yes, positive 2, negative 3. Negative 3, positive 2. So now these can cancel. So I have x minus 2 over x minus 3. Okay, if those cancel, that means that x cannot equal that. Okay? So it cannot equal negative 2, right? X cannot equal negative 2 because it's been canceled out. Which allows me to then start to solve some stuff. Yay. So, yeah, okay. So then I can set this bottom equal to 0, which is x minus 3 equals 0. So x cannot equal 3, correct? Okay, so at 3, I have a horizontal or vertical asymptote. The top, the squares are the same, so I find my vertical asymptote, my horizontal asymptote by taking the leading coefficients. So y cannot equal 1. And this graph doesn't change, so I'm going to have something in this quadrant and something in this quadrant. This quadrant, this quadrant. Now we plug in numbers. Okay, so I can just start plugging in things. I'm going to plug in 4 and 6 so that I can solve this. If I plug in a 4 and a 4, I would get 4 minus 2 over 4 minus 3, which gives you 2 over 1. So 4, 2 is a solution. If I plug in 6, I have 6 minus 2 over 6 minus 3, which gives you 4 over 3. So when you plug in 6, you get 1 1/3 as your solution. So this is going like this. I'm going to plug in numbers over on this side. I'm going to go ahead and plug in 2 and 0 and probably negative 2. If I plug in 2, I have 2 minus 2 over 2 minus 3, so 0 over negative 1. So when I plug in 2, I get 0 as my output. When I plug in 0, I have 0 minus 2 over 0 minus 3, which gives me 2/3. So 0 and 2/3 is the solution. 0, 2/3. When I plug in negative 2, I have negative 2 minus 2 over negative 2 minus 3. So I get negative 4 over negative 5, so I get 4/5. So negative 2 and 4/5. Negative 2 and 4/5. So this one's going to go like this. Okay. So that's graphing that. Okay, last one has a radical in the denominator spot. What do I do if there are radicals in the denominator spot? How do I solve when there's a radical in the denominator spot? Well, what do you mean squared or something? Sort of.
You multiply the top and bottom by the denominator? The opposite of the denominator?
Not exactly. If I have a square root function in the bottom. You mean you want to get the radical out of the bottom and then graph it from there? Is that what you're saying? Okay.
So maybe I have to.
Or if I take the square root of x squared plus 1 and set equal to 0, how do I solve from there? I would square this, right, so that this cancels and you get x squared plus 1 equals 0. Now, here's the deal. You get x squared equals negative 1. What do you know about when you take the square root of a negative number? What do you get? I. Plus or minus I. So you have an imaginary solutions happening here. Okay? When I set this bottom portion, x squared plus 1 equal to 0, right? That's where I get that imaginary solution. So my graph is going to look a little bit different on this one because it has to deal with imaginary stuff. So if I were to plug numbers in here, let's say I plug in, if I plug a 1 in, or I'm sorry, if I plug a negative 1 in, it would give me 2 in here, right? Because negative 1 squared is 1. Okay, what number gives me 0 in there? Just imaginary solutions, yes? Okay, because I set it equal to 0 and I solved, and that's what happened. So I can technically plug any number into that denominator's problem and get something out. Because if I plug a 0 in, I have the square root of 1. Okay, if I plug a 0 up top, you have a 0 over the square root of 1, which is just 0. So technically, my turning point here is going to be at 0, 0. Okay, because I plug numbers in. From here, I'm just going to plug things in. Because what happens is, we prove that when we set this portion equal to 0, I get imaginary solutions. Which means technically I can set any number in there and still be fine. So if I plug a 1 in, okay, you get 6 times 1 over the square root of 1 squared plus 1. So I get 6 over radical 2. Yes? And 6 divided by radical 2 is like 4.2. So when you plug in a 1, you get something like 4.2 out. Okay. So if I plugged in a negative 1, I'm also going to get a 4.2 out, right? Ooh, that doesn't make sense. Parker.
You're the worst whisperer ever.
So what happens is I'm going to get a graph that comes and looks like this. It's going to mirror itself. Yeah. You're going to have more in your homework. And that's the graphing we're working on today.
Oh, you want to have a lot of equation radicals in it?
You'll have some, yes.
Wow.
You can use your graphic calculator. You still just have to show me the work to check it.